Make an oscilloscope text display using only one Pico I/O pin. You will need a Raspberry Pi Pico with pins, a USB cable, a 1K ohm resistor, a 470 picofarad capacitor, and a couple jumper wires. This is a breadboard project. Use any size that you have. The display is a 7-line raster scan. To eliminate intensity modulation, the on pixel is stepped to the scan line from a base level, then returned to the base for the off level. 7 sweeps are required to form the text line. Analog scopes have a persistence in the phosphor that retain the line scans. They're ideal for viewing. Digital scopes may require some setup to form a good image. Each line start is triggered on a rising edge from 0 volts. This is followed by a front porch delay. Next, pixel data is sent for 50 characters. A back porch delay is inserted. The voltage then drops back to 0. The Pico processor does not have a digital to analog converter. We use a very fast pulse width modulated, or PWM output, running around 8 MHz. The PWM has 16 levels, or 4 bits of resolution. The 3.3 volt PWM signal is reduced to a DC level using an RC low-pass filter. The 1K resistor, 470 picofarad capacitor, filters ripple to around 140 millivolts peak to peak. The bit changes will still be distinct as each bit step is 206 millivolts. The partially filtered PWM allows a fast rise and fall time. The Pico code is written using the Arduino IDE and Earl Philhauer's Arduino Pico. The processor clock is set to 150 MHz, the optimization to -0, and the USB Stack to Pico SDK. Several Pico libraries are required. We want the PWM slice to be available after setup, and we use a global variable. Setup code performs the following. Pin 14 is set to the PWM output. The PWM wrap is set to 15, which gives 16 levels. The clock divider is set to 1 to give a PWM clock of around 8 MHz. The PWM value is set to 0, then enabled. The Core 2 program generates the raster scan by writing synchronization and pixel levels to PWM pin 14. Pixels are locked to the microsecond system clock by testing the counter value bits. The delay is twice the sync bit value. Sync bit must be a multiple of 2. Most of the program code is the 128 ASCII character values. Characters are 5 pixels wide with 2 blank pixels for spacing. Pixels transitions are synchronized to the system microsecond clock register at 16 microseconds. For delay times other than 2 to the n, the microsecond delay function may be used. Since the display generator runs on Core 2, this leaves Core 1 for processing other tasks. In our case, Core 1 is used to receive serial data and store characters in the ASCII line array. Display on an analog oscilloscope may require a reduced character count. The bandwidth and trigger limitations of the ICO Model 460 oscilloscope limit the display to 20 characters. Digital oscilloscopes may not have a variable horizontal timescale. To display on a fixed horizontal scale, the program delays need adjustment, where the number of characters plus sync pulse will exceed the horizontal time per division multiplied by the number of divisions. The time displaying characters must be slightly less. For our Rigel DS 1074 oscilloscope, we have 1,000 microsecond sync, two 240 microsecond delays, and 50 character times 7 times 16 microseconds per pixel. This results in a line scan period of 7.08 milliseconds. The oscilloscope was set to 500 microseconds per division. With 12 divisions, the scan time is 6 milliseconds. The character time is 5.6 microseconds. In addition to triggering on the line scans, display options may need setting. Large memory storage depths cause display delays and rolling dark bands. Low values can fix this problem. Dot mode displays look better than vector mode, as the rising and falling edges do not overlap the character display. Some digital oscilloscopes may not have a dot display mode. A persistence display was used with this diligent analog discovery oscilloscope. To obtain a clearer image, the color mode was set to dark with a monotrace color. The number of characters was reduced to half at 25. Source code and the program file scope writer can be found at